Howdy, we are Texas A&M's Autonomous Underwater Vehicle Team, or AUV. We are an all-women's project team under the Women in Engineering program.
The goals of our team are initially to just build an autonomous underwater vehicle that is able to function at the RoboSub competition. Beyond that, we are a learning team. So our long-term goal is to develop well-educated engineers that are able to speak up for themselves and work well in team environments.
On this team, we use an iterative design process. We evaluate our previous year's vehicle as well as vehicles on other teams. There's so much that we can learn from what other teams are doing at competition.
Every year on AUV, we go through a design phase and then a fabrication phase. And this year we're going to be able to have a testing phase.
We'll look at it as a team, we'll come up with a lot of different ideas, and then we'll dive into it even more. We'll have an individual group of girls look at that, they'll come up with the design.
During this process, it's a lot more interactive because we have to keep accessibility and manufacturing in mind. For instance, do we have the resources to iodize something? Do we have the funding? Do we have the capability or the machinery? This year's vehicle is a lot more ambitious than the other years, because initially we set out with the goal of just redesigning the frame every year to give everyone an equal opportunity for the experience. However, we realized that the manufacturing experience could also be applied to the mechatronics components. For this year, our technical expectations are to upgrade the internal components because we have luckily been gifted a Jetson, which is a new processing component, and it will allow us to become more accurate with our buoyancy.
This year, we're going to actually be modifying Minnow to meet our new needs, such as fitting the NVIDIA Jetson. This is the first year that we've ever reused a vehicle. We're even using parts of Nessie, such as the mid-cap that we're resizing to fit the NVIDIA.
So this year we have a new camera that allows us to have depth perception because it has two cameras in one component. In order to accommodate our new cameras, we have to create new end caps that have a hole in them so that the camera can see through our housing.
So we were met with a lot of challenges, especially this past year. Anything that has to deal with power has consistently been an issue that we are coming up with a lot of ideas lately to try and overcome. Instead of using the analog cameras that we were using, which were for the forward-facing cameras that we had, we're going to use a new camera system.
The goal of the programming team specifically is implementing different things like machine learning, object detection, and thruster control to make sure that the vehicle is performing as efficiently as it can.
Some challenges we faced in programming is that we were able to get our object detection working, but we were not able to get our vehicle to track our object and react to what it saw. Some technical expectations I have for this year, specifically for the programming sub-team, is implementing ROS, which is a robot operating system. In addition, we are also looking into implementing a vector nav, which helps our vehicle know where it is and the position of the vehicle in the water, which is really important and would be really useful for our competition.
So for the object detection, we used Python's OpenCV library. They have a lot of different functions that help us with drawing boundaries around things and detecting specific colors. That helps us with seeing underwater and pre-processing images. For the sensors, we use the sensor libraries from the company we bought them from, and we also are using ROS, which is a robot operating system, to kind of put it all together and be able to run different pieces of code simultaneously.
So in the past, our overall designs for the AUVs have been pretty successful, and as the years go by, we've just been working on perfecting them.